Hi, my name is Margaret. In this video we're going to have a closer look at defensive copies. We are going to see why we need them. In order to do that, we write an example without defensive copies and look how it affects the data integrity. Then we are going to explore the memory allocation. That will help us understand what is going on and how we can fix it. And then we are going to fix it by implementing defensive copies and also verify that the data is now protected. The example is going to use a class top 3. And this class has two fields. It has the top 3 winners of a competition, and either it's a national competition or not. We have a constructor, a getter for each of the fields, and then we have a method that displays the winners. This is the implementation of the UML class diagram I just showed you. We have the top winners, string array with the names of the top 3. It's a national competition, that's a Boolean value. We have a constructor. This is a boilerplate implementation that was auto-generated by Eclipse. Same thing is true for the getters. I even skipped the doc comments because it just does the typical things getters do when you auto-implement them. And then I have a method that displays the winners. It either says national winners or winners, depending on whether it's a national competition, and then it lists the top 3 contestants based on the array. Now we're going to create a top 3 object, and we're going to look how this works. Here you can see I created a string. It has the 3 winners of a math competition, Alex, Mia, and Ron. And I create a top 3 object. This is my top 3 math. It includes the 3 winners, and yes, it was a national competition, and we're going to display the winners. Let's see how this goes. I'm going to run it, and here you can see our top winners are Alex, Mia, and Ron, and everything seems perfectly fine. And at this point, I'm happy with my top 3 class. I might just say, well, now that we represented and displayed the top 3 winners of the math competition, I would like to do something else for a second competition, which is a art competition. So here you can see I was assigning the new winners. So my winner in the art competition was Chris, second place Dale, third place Gina. And so I'm going to create an object top 3 art. And it includes the winners. No, this was not a national competition. And we're going to display the winners of our art competition. Let's run that. And you can see my national winners. Those are the ones from the math competition, Alex, Mia, and Ron. And the winners from our local art competition, Chris, Dale, and Gina. And again, everything seems fine. And so at this point, I might have somebody who comes in and says, hey, can you display the winners of the math competition one more time? And says, absolutely no problem. We just did this before, right? So I'm going to grab my winners from the math competition, and let's just say display math competition winners again. And I'm going to run it. And all of a sudden, my national winners from my national math competitions are Chris, Dale, and Gina. But they surely used to be Alex, Mia, and Ron. And so this is why we need a defensive copy. I was just auto-generating the implementation of my getters and of my constructor, so I didn't even write this code. This came straight from Eclipse. And I look at my output and something is clearly wrong. And at this point we are going to have a look at the memory allocation to understand what is going on. So this is part 2, explore the memory allocation. You can see that I started already the drawing. I started by adding the array A on my stack. Array is a reference type, so it references an object on the heap, an array object. Now, because my array has elements of type string, which are references themselves, each of those elements would be a reference to a separate string. And you can see it starts to get complex quite quickly, so I'm going to simplify a little bit. Now that I showed you that each of those array elements actually would be a reference itself, I'm going to take that out and move the string directly in the array. So that's a little bit of a simplification, but let's just draw it this way to focus on the essential parts here. So we have an array that includes Alex, Mia, and Ron. So the next thing we created was the top3 math variable that is a top3 object. So here we are going to draw that object. It was an object that has 2 arguments. One of the argument was the winners. So here we have the winners. I'm going to push up the winners, and this is just a label to add some clarity, make it a little bit easier to see. And now I want to draw the reference from my winners exactly where that reference was already, to that same object, because we assigned A to winners. That's what happens. We just copied that address. So same address, same reference to the same object on the heap. In addition, we also had the national attribute, so that happened to be true. And after we created the object, we assigned it to the top3 math right here. And when we said top3 math display winners, then top3 math would check what are those winners, would find this is Alex, Mia, and Ron, and it will print that. Now, after we were done with top3 math, we went to the array A and we decided to store different winners there. So instead of Alex and Mia and Ron, we decided to store the new art winners, which happened to be Chris and Dale and Gina. So you can see those were the new references. And in addition, we created a new variable, top3 art, and we created a new object that referenced the array A. So again, we had the winners, and the winners pointed to A. And we also had a second attribute, national. In that case, it happened to be false. And once this object was created, we were able to assign it to top3 art. And when we printed top3 art, and we said top3 art display winners, it would check what are those winners. It would find those are the winners from this array. It would print Chris, Dale, and Gina. But afterwards, when we went back and said, hey, let's print the top3 math winners again, top3 math would check what are the winners, and it would find here Chris, Dale, and Gina, because all 3 variables, winners from top3 art, winners from top3 math, and A, are referencing one and the same object, the array object that has been modified. That obviously didn't work too well, so what can be done about it? We can add a defensive copy to our code, so every time we create a new instance of top3, the array that is passed as an argument is going to be copied, and each of the different objects, the different top3 objects, references its own array on the heap. At this point, we're going to move on to point 3, and I'm going to show you how to implement defensive copies. So here I'm back in my source code, and I make one modification. I'm taking out the second top 3 object, the one for the art competition, to make the memory allocation diagram a little bit simpler. And I'm going to show that it's just changing the original array impacted the math competition winners. So here I'm going to run my code again. And you can see my math national winners were changed just because the elements of array A were changed. So what I'm going to do is the following. I'm going back to top 3, the class, and I'm going to create a defensive copy. You can see here in this line, I assigned winners to the field winners. That's when we created the reference to the existing array object. I don't want to do that. I want to create a second array that is a copy of the original one. And I can do this using class arrays. So here is arrays, copy of, and you can see there are lots of overloaded methods. I'm going to take one that allows me to specify a reference type, any reference type T, and the length. So here I'm going to say, well, we are going to have a array of a reference type that is winners, and then I would like to have the length. So this is winners.length. And now I'm going to import arrays, and this change creates a defensive copy. Now my field winners no longer references the original object, but a second copy of that object. So here it says defensive copy. And I'm going to show you how the changed memory looks like. So here you can see the updated memory allocation. The big difference is the second array here on the heap. It was created when the top 3 object was created in the constructor when we called arrays copy of. So originally my array A pointed to an array that included Alex, Mia, and Ron. When we created the top 3 object here, we created a whole copy of the array, second object, and later on when we updated the values to Chris, Dale, and Gina, that had no effect on the top 3 object right here that is referenced by top 3 math. So when I run the code again, I would expect that both times the top 3 math competitors are displayed. Let's try it. And here you can see both times it shows it's Alex, Mia, and Ron. And at this point we might just feel good and think everything is fine. Now the data integrity of our top 3 object is guaranteed. But let's consider something else. Let's consider the use of the getters. So here I say calling get winners. So here I have a string array. Those are the winners, or it says my winners. And how do I get the winners? I'm going to go to top 3 math, and I'm going to say get winners. And I might display the winners. I can do that by calling the toString method of arrays. Here we are. Let's run the code and look at it. And you can see, not surprisingly, it shows me my winners are Alex, Mia, and Ron. So what would happen if I update the variable my winners and I say, well, the actual winner, that is me. So here I'm going to print it again, and I would expect to say that my winners are me, Mia, and Ron. Let's try it. So here we are, me, Mia, Ron. The question is, could that possibly have any impact on top 3 math display winners? Now you can see here, I didn't do anything to top 3 math. I was just putting me on position 1 of my winners. But to be sure, let's just have a look. I added an empty line called top 3 math display winners again, and I'm going to run the code. So here you can see the national winners are me, Mia, and Ron. So question is, how can that be? And to find out, we're going to have a second look at the memory allocation. Here you can see what happened. When we called get winners, it returned winners. Now winners is a reference type. So when we return winners, it returns a reference to the very object that is used by the field. The reference here is drawn as an arrow, but really you can think of it like an address. So it gives the address to my winners. Now my winners has a reference to the very same object on the heap. Originally it said Alex, Mia, and Ron, but then when my winners was changed to me, Mia, Ron, that also affected the top 3 object. So what can we do about it? We once again need a defensive copy. Let's do that. So here I'm back in my class top 3. Notice last time we created a copy when we received a mutable object, this is our array, from the outside as a argument value for the parameter winners here. And we created this copy to make sure that whatever the field is referencing cannot be changed outside. Now, I have to do the same thing when I return winners. In this case, I only do it for the method get winners, but there could be other methods as well that return a mutable field. So we have to check for all the methods. If it returns a mutable field, we need to make a defensive copy. I'm going to use the same statement I used before. I'm going to simplify in a second. So here I might just say this is the winner's copy, and now we are no longer referencing the returning the field, we are returning a copy of the field. You might notice there is no benefit in creating this variable just to temporarily store it and return it. So I'm going to return arrays copy of directly. So here I can return that directly, no need to store this temporarily. I just showed that intermediary step for extra clarity what is happening here. So this copy of method gives me the copy of the winners, which happens to be a string array. That's important because get winners promised a string array. And now we return a separate third array on the heap. Let's have a look at the memory allocation. This time when the getter was called, the getter did not return a reference to the array that is used by the field, but it returned a copy. So it created a copy which was Alex, Mia, and Ron, and a reference to that very copy was returned and stored by my winner. And then later on, when my winner said, well, actually the winner on position 0, that is me, that only affected the copy of the array. So let's look back to the code and make sure it works as expected. Here I'm going to my demo, I'm going to run it. And you can see my winners was changed to me, Mia, and Ron, but the national winners from the math competition were no longer affected. And so here's a takeaway to our elaboration on defensive copies. Whenever you receive a mutable object to initialize a field, create a defensive copy. That is typically done in a constructor when you receive an argument of a mutable type, or a setter. But it's possible that this could happen in a different method as well, so you have to check for it. When you return a mutable field, return a defensive copy. Pay special attention to getters, but again, watch out for all methods, because any other method could also potentially return a mutable field. So how do you know whether a type is mutable? Primitive types are never mutable. No defensive copies are needed for primitive types. There are also some types, like strings, for example, they are immutable. They cannot be changed. No defensive copies are needed for strings or any other immutable type. But arrays, collections, etc., they can be changed. And if they can be changed, we have to be careful. And because of that, we need to create defensive copies. That was it for today. Have a great day.